Welcome to the lecture on bivariate scatter diagrams and contingency tables. We're only going to be going over bivariate scatter diagrams in this lecture right now, and we'll do a separate lecture on contingency tables. So by the conclusion of this lesson, you'll be able to create and interpret a scatter diagram. So what is a scatter diagram? You guys have probably seen scatter diagrams. These are examples of scatter diagrams. And so we're going to look into what a scatter diagram actually is. So a scatter diagram is a graphical tool to portray the relationship between two variables or bivariate data. So we've been talking mainly about univariate data. Univariate data means you are only looking at one variable, okay? Or only one variable actually varies. But when you're looking at bivariate data, you're looking at two variables that are varying, and they have a relationship with each other. So in order to do a bivariate scatter plot, both variables have to be measured with interval or ratio level scales. In other words, both variables have to be quantitative. You cannot use a qualitative variable. For instance, you cannot use what is your favorite genre of movie and have a bivariate scatter plot with how many minutes did you spend yesterday watching TV or streaming media. That would not be a bivariate scatter plot. Okay. So you need to utilize two variables such as how many text messages did you send yesterday and what is your ideal summer temperature. So if I were to say highlight the two of these and I were to do insert recommended chart, I could go down here and I could say, hey, I want an XY scatter plot. Okay, and you can see I've got a scatter plot right here, and I'm going to zoom in on the data a little bit. I'm going to, let's see, 55 for the minimum, 105 for the maximum. And you can see right here, the vertical axis is how many text messages they sent yesterday. And then the horizontal axis is what their ideal summer temperature is. So let's take a look at what this really is, okay? Right here, I'm going to tell you straight up, we've got 103 data points on this chart, okay? How do I know that we have 103 data points on this chart? The reason why I know that is because there are a total of 103 people who have answered this survey. Okay, so say for instance I'm going to do a slightly different, I'll do the same exact thing, okay? So temp and text. So say my ideal summer temperature is 60 degrees and I sent 100 text messages yesterday, okay? Another individual's ideal temperature is 70 degrees and they sent 90. Okay, another individual is 80, their ideal summer temperature, and they sent 80 text messages. And then another individual's ideal summer temperature is 90 degrees and they sent a total of 70 text messages. And you can see the trend that I've got going on here, and this trend is important because I'm going to show you something in just a minute. So individuals whose ideal summer temperature is 100, they sent a total of 60 text messages. So I'm going to insert. I can just click on this right here. And you will see that there is a nice straight line. Okay, so this right here is, well, it's kind of hard to tell because, let's see here. I'll make it a little easier. There we go. Okay, so now we know that their ideal summer temperature is 110. So this right here is the temperature axis, and this right here is the number of text messages. Okay, and these are inversely related. So I'm gonna zoom in on this a little bit more so you guys can see this. I'm gonna make the minimum on the horizontal axis. Let's make it 65, and it'll go to 115. Okay, and then I'll make the minimum on the vertical axis. Let's see here. We'll make that 55 to 105. Okay, so what you can see here is horizontal axis is 110. Okay, and vertical axis is 60. So temperature is 110 and text messages is 50. So you come over here, 110, 60, and they've got a point there. Okay, and then you come right here, we've got 100 degrees and 70 text messages. 100 degrees, 70 text messages. Okay, 90 degrees, 80 text messages. 90 degrees, 80 text messages. 80 degrees, 90 text messages. 80, 90, then finally 70 degrees, 100 text messages. So you can see in a bivariate scatter plot, essentially what you're doing is you are graphing the x and the y coordinates. So you've got x and you've got the y. So this is the x-axis and this is the y-axis, and that makes your scatter plot. So this right here, these are all the scores on the x-axis, and these are all the scores on the y-axis, and they represent the actual data points and how they interact to make, or how they relate, not interact, but how they relate to make a scatter plot. Okay? So that is how you make a scatter plot with x and y axis. Okay. Oops. Okay. So if the scatter points move from the lower left corner, so if they move, let me move this right over here. If they move from the bottom left corner to the top right corner, then the relationship is considered to be positively related or directly related. Okay, if the scatter plot points move from the upper left corner to the bottom right corner, then it's considered to be negatively or inversely related. Okay, so in my made-up scenario with the text messages and the temperature, that would be said to be negatively related. Okay, negatively related. So let's take a little quiz here. Looking at these scatter diagrams, the first scatter diagram, is that positively or negatively related? Positively or negatively related? Okay, and the answer would be it's moving from the bottom left corner to the top right corner. It is positively related. Okay, the next one, auction price, and you can see it makes sense because this particular graph, what it's saying is as a bus gets older, the cost of maintenance on that bus increases. So the age of the bus and the cost of maintenance is positively related. So next, miles on the odometer to the auction price. So they're selling buses at an auction, and they want to see, based on the miles on the odometer, how is that related to the price that they're going to get at the auction? Is that positively related or negatively related? And you can see that the dots are going from the top left corner to the bottom right corner, so that would be negatively related. Okay. The next one, height versus salary. They want to know, depending on the height of an individual, does it influence or is it correlated? Is it related to the salary? And you can see these dots are all over the place, and there really is no relationship at all. Okay, so X to Y, over here back on the chart, or back on the Excel chart, you can see that this is inversely or negatively related As individuals, the higher an individual's ideal temperature is, the lower number of text messages they sent yesterday. Now, you may be looking at the original chart from the actual data and saying, okay, well, I can't really tell, is that positively related or is that negatively related? And sometimes you're going to look at charts and you're not going to be able to tell right away. And Excel has this really great function in here. We can go to Design and we can do Add Element. And we can do Trend Line and add a linear trend line. And you can tell based on this linear trend line, it is negatively related. Negatively related. Now, I've actually done a little bit more work on this, and I was able to determine that based on knowledge of individuals' ideal temperature, it contributes to knowledge of about 3% of the variation of individuals of how many text messages they sent out. So it's not very strongly negatively related, but it is negatively related. And we'll get into that a little bit later. But right now I just kind of wanted to show you there is a tool that even when you can't tell things right away, you can click on it and you can go Design and you can say Add Chart Element, show me the trend line. Okay. So that ends our lecture on scatter diagrams. If you have any questions, feel free to post them on the discussion board.